What should we do if we have an equation in which fractions appear either as coefficients or as constants? For example, what should we do if we want to solve the equation 3/5 x plus 7/12 equals 1/5 x minus 2/3? Now, we absolutely have the option available to us of solving this like any other equation. The numbers in this equation happen to be fractions, but that's okay. We know how to do fraction arithmetic. I'm going to call on my calculator to help me in this process. So I'm starting with 3/5 x plus 7/12 equals 1/5 x minus 2/3. First, I want to get rid of this 1/5 x, and I'm going to do that by adding negative 1/5 x on both sides. These fractions have the same denominator, so I don't need the calculator yet. 3/5 minus 1/5 is 2/5. I haven't done anything with the 7/12 yet. 1/5 x minus 1/5 x is just 0. I'm just left with negative 2/3 on the right. Next, I want to eliminate this 7/12 term. I want to do that by adding negative 7/12 on both sides. On the left, that gives me 2/5 x plus 0, but I don't need to write that. On the right, I have negative 2/3 plus negative 7/12. Oh, I can leave that as a decimal, but I think I want it as a fraction. Negative 5/4. And now to get rid of the 2/5, I'll multiply both sides by 5/2. And I'll get on the left just x. On the right, negative 5/4 times 5/2 as a fraction is negative 25/8. Checking my work, 3/5 times negative 25/8 plus 7/12 gives me 3/5 times negative 25/8 plus 7/12 as a fraction is negative 31/24. On the other hand, 1/5 times negative 25/8 minus 2/3 is 1/5 times negative 25/8 minus 2/3 as a fraction. Again, negative 31/24. No problem. When we encounter an equation in which fractions appear, we can solve it just like any other equation and have the calculator help us with the relative inconvenience of fraction arithmetic. If you want to use this option every single time you solve an equation with fraction coefficients, absolutely do that. In fact, if you want to, you can stop watching this video right now. However, You may in the past have seen an alternate method for solving an equation in which fractions appear as coefficients. And I want to discuss that method just so that you know what's going on. Say we have the equation, same equation again, 3/5 x plus 7/12 equals 1/5 x minus 2/3. Our second option is to multiply on both sides by what? By a common multiple of the denominators. So the denominators I see here are 5, 12, 5 again, and 3. 5 is prime. 12 factors as 3 times 4, and 4 factors as 2 times 2. 5 is still prime, 3 is prime. So the least common multiple of these denominators is 5 times, for 12 I need a 3 and 2 2's. And that's it. I already have a 5. I already have a 3. So working out this arithmetic, I'll have 5 times 3 times 4 is 15 times 4 is 60. I'm going to start by multiplying both sides by 60. So I'm going to write it as 60 over 1, because I need to multiply it with some fractions, times 3/5 x plus 7/12. On the right again, 60 over 1 times 1/5 x minus 2/3. Distributing on both sides, I'll have 180 over 5 times x plus 420 over 12 equals 60 over 5 times x minus 120 over 3. Why is that better? For each of these numbers now, I can do division, and I will get a whole number. So in other words, 180 divided by 5 is 36. So I'll have 36x. 420 divided by 12 is 35. So I'll have 35. 60 divided by 5 is 12. So I'll have 12x. 120 divided by 3 is 40. The advantage here is that now, for the rest of the solving process, we can do integer arithmetic. The disadvantage, of course, is all of the work involved in getting here. And you see, next we eliminate the 12x by adding negative 12x on both sides. We eliminate the 35 by adding negative 35 on both sides. I'm going to start a new column here because I'm running out of space. We divide both sides by 24, and we get x equals negative 75/24. Finally, noticing that 3 is a common factor, we get that same negative 25/8 that we had earlier. We get the same solution either way. The arithmetic is a little bit easier with this method, but the process is so much easier if we stick with the fractions. If you have never learned to solve equations like this before, you should prefer this option. However, if you prefer to solve by eliminating the denominators, that method is also correct.